Day 408 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 357, count numbers with unique digits. The difficulty level is medium, so don't even worry. We're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the integer n, return the count of all numbers with unique digits x, where 0 is less than or equal to x and x is less than 10 to the nth power. So that can seem a little bit confusing, y'all. So let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have n equals 2. The output is 91. Explanation says the answer should be the total numbers in the range of 0, where 0 is less than or equal to x, x is less than 100, excluding 11, 22, 33, 44, 55, 66, 77, 88, and 99. So let's go ahead and break this down one step further so we can make sure we really understand what's going on. So in this case, n equals 2. So n equals 2, that means we want to find all of the unique digits, return the count of all numbers with the unique digits, which is x, which is 0 is less than or equal to x, and x is less than 10 to the nth power. So as you can see, 10 to the nth power, in this case n equals 2, so 10 to the second power is going to give us 100. That's where this 100 comes from. Then we want to find all of the numbers in this range from 0 to 100 where they do not have duplicate numbers, right? So these numbers right here all have duplicates. These are not unique digits, right? 11 has 2 1s, so it has a 1 and a 1, meaning 1 is not unique. Same with 22. 22 has 2 2s, which means it has a 2 and a 2, which means the 2s are not unique. Same with 33, has 2 3s, which means 3 is not a unique digit. So as you can see, and all of these numbers right here, they don't have unique digits. These digits are the same. We want to count all of the numbers with unique digits. That's why these are the numbers we exclude from our count. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9 digits that we exclude from our count up to 100 because we're choosing 100 because n equals 2 and 10 to the second power is 100. So then we find all of the numbers that have unique digits. These do not have unique digits, so we can subtract these from 100. And once we subtract these 9 digits or these 9 numbers from 100, then we get 91, right? So each number has 2 digits in this case, right? These are 2 digits numbers, right? Even though it's one number, it has 2 digits. Like it has 1 9 or it has 2 9s. That's 2 different digits, and we want the unique digits. So I hope that makes sense to y'all. So let's go ahead and take a look at example 2. Example 2, in this case, n equals 0. And when you multiply 10 to the 0 power, that gives us the output of 1, which is why our answer is 1. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution's not that difficult, so let's get started. First thing we're going to do is we're going to check if n is 0. That means there's only one valid number, right, which is 0, and n is greater than 0, so else we could just return 1. So we're going to say guard n is greater than 0, else we could just open up the brackets and we could return 1. Like you said, or excuse me, like I said earlier, a number to the 0 power is always going to be 1. So if n equals 0, it's going to be up to 10 to the 0 power, which will always be 1. So we can always return 1 if n does not equal, if n does equal 0. So we want n to not equal 0 or be greater than 0. That's what we're checking with this guard statement right here. Boom. Then if we're going to create a variable x, which will store the total count of unique digit numbers, right? And we're going to start from 1 to include the number 0. So for that, we'll come right here, declare a variable, call it x, we'll set that equal to 1. Boom. Then we're going to iterate over number lengths from 1 to n. So for I n 1 dot 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 n, we're going to open up the brackets, and the first digit can be from 1 to 9, right? So we're going to exclude 0. So we're going to declare a variable called result, and we're going to set that equal to 9. Boom. Then for the remaining I through or I minus 1 digits, we're going to choose from the remaining digits. It will be 10 total digits minus the used digits. So for that, we're going to come right here and we're going to say for jn1 dot dot less than sign I, open up the brackets, and we are going to say result times equals 10 minus j. Boom, just like that. Then we're going to add the count of the I-digit unique numbers to the total. So for that, we come underneath this, and we are going to say x plus equals result. Boom. Then we're going to return the total count of numbers with unique digits from 0 to the largest n-digit number. So we're just, all we have to do is come right here and say return x. And it's that simple, y'all. That's all the code she wrote. So let's go ahead and give this a run. Make sure it runs properly before we submit it. Let's see, and it's accepted. So let's go ahead and submit this and make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.